where we build and maintain the data services that are used by Skyscanner to get their data needs. And I'm going to talk about one of those areas, which is actually data production, so how people get their data in. So this is going to be a talk more focused on the engineering side rather than the data science side. So I'm going to take you on a journey about how we kind of enabled everybody to log everything super, super easy. And what we did is we set ourselves a goal right at the beginning when we did this. And we said that any engineer within Skyscanner can log data, whether that's critical event data, application logs, metrics, whatever it was, retrieve it, generate some basic out-of-the-box metrics, and do all that within minutes. Super, super easy. So in order to do that, we looked at what our current data platform was. I'm going to introduce it to you now. It's called Grappler. Why is it called Grappler? Because the grapplers are like the hook things that pick your logs up and move them from one place to another. But that's what it actually looks like here. So it's the main thing that it's built on top of is Apache Kafka. If you're not familiar with that, it's a unified log. It's a distributed message log, which has like pub/sub capabilities. So we have our different data sources out here. They're either writing directly to Kafka or via a HTTP interface, where it's not actually possible to do that. We then have stream processing on top of Kafka, where we use SAMSA. And then we transport the data from Kafka to two main areas. One which is our data archive, where we use S3. And that's actually then processed and put into Redshift as well, so people can do queries on top of that. And there's actually Tableau on top of Redshift. And then for more real-time needs, we'll take data and we'll put it into, we use OpenTSDB for our time series data, and then Grafana on top of that. And then an ELK stack down the bottom. The Elasticsearch, we have, most of our data has a retention of about 7 days. So that's really for you just want to look at the data now, and then we'll dump it out, and then if you want to look at it later, you can look in S3. So that's kind of cool. Let's look at some use cases of how that's used in Skyscanner. Some of the guys have already talked about some of the ways that it's used. Here's some more. So the indicative prices for car hire. So you can see down here we say someone's done a search between Edinburgh to London, and we look at all the different quotes from the different car hire companies that come through the platform. We use SAMSA to do processing on top of that, so we look at different dimensions such as city and day, and then we can generate that price there so that potentially we can get an upsell on someone buying a flight. Another area, another product that we supply is something back to our partners called Flights Connect. So this looks at various different data from different sources, and then the partners can look at this so they can say, okay, so different markets, how are people searching here, or different times of day, and they can look at this and get different analytics of that. And that's pulled from all the different data that's coming in, aggregated together and provided back to them. So that was kind of cool, but what wasn't working? What made it hard for people to be able to log everything? The first thing for this was that onboarding was quite slow. So something I didn't mention is that all the data that goes through the platform, we use protocol buffers to serialize all the data. And we kind of had this requirement that every new data set that came in, you had to generate a schema. And this is quite a thoughtful process. You have to go through, it's quite time consuming, and it slowed things down. The other is, while we did have automation, there was it was all sort of Ansible based. Someone had to go click buttons on all the different services in order to make sure everything got kind of forwarded. The other one is we had kind of a lack of standards. So we had lots of multi-tenant topics with no naming conventions. So a topic is sort of like a data stream in Kafka. So when I say multi-topic, I might say like you have all your application logs going into one topic. But then which service is putting into which different logs. There was no standardized way for our different producers and our different services to deal with write failures. So some, when they weren't able to write to Kafka or to the HTTP interface, they would just fail and they would just drop the messages. Others would write locally to disk and then replay them later. So it was all a bit kind of all over the place. The thing that we did is we took all that big technology and we said, we don't want you to think about that. We don't want you to think about writing to Grappler. We want you, or thinking about writing to Kafka. We want you to think about writing to Grappler. So we really just, we built a load of SDKs, and that was kind of the core around this. So we targeted the 4 main languages that we use within Skyscanner, and built those out. So for application logs, what we did is we hooked into the existing logging libraries that you have. Now the thing about this is this doesn't replace all the other schemas that are in there. This is kind of like the gateway drug in order to get you to start logging things into the platform. So if you've got a service, you just want to start doing some experiments, but you don't want to have to build out an entire schema, you can just use this to quickly logging data. For more critical data, people will still generate schemas. Again, super easy to add time series metrics. So there's what a function would look like in Python if you just wanted to start logging metrics. And then straight away these come up and appear in Grafana. I mentioned we had a lot of these multi-tenant topics. We decided to kind of split them out. and generate kind of conventions around them as well. So there's two main things that we wanted. We wanted them to be human readable, so that if we suddenly got a spike through one topic, we were able to see where that service was coming from, what it was responsible for. So that's kind of like the schema that we went for the names of our topics, so what the environment was, the service, what event, and then the actual schema and message type. The other thing about these is that they were also machine readable, so that we could start to build automation around this in order to get people onboarded much quicker. So the automation that we built, we effectively use, all our stuff is built on AWS. We have a Lambda which periodically will look at Kafka and look for the new topics that have appeared in there. And then we'll actually talk to a configuration microservice. And so that will go set up everything that you want. It'll give you your default topic policy, so you have the correct amount of retention for the data that's in there. Set up your Logstash folders, Kibana indexes, all that kind of stuff that we were doing manually with Ansible scripts before. The other thing, into the SDKs, we built in our own fallback mechanism. So that when we have, you're not able to write to Kafka or HTTP interface for whatever reason, we'll fall back and we'll write directly to S3. We then have a replay service, which is constantly monitoring the data that's in S3, and that actually pushes it back through Kafka. And we find that we actually get about, around 1 million messages that still actually do fall back to this, that we capture, and need to play back in again. So, it is playing quite a good role. So what are the results of doing all this? Where did we kind of come? It does actually take minutes to start logging data through the platform. I think it's about 5 minutes from when you start logging data in order to actually see it in Kibana in the other end. And that's setting up all the different pieces of infrastructure that need to happen along the way. We currently have about 250 services within Skyscanner using our SDK in various different forms, from critical event data to just application logs. These numbers are a bit out of date. They're actually a bit bigger now. So about 100,000 messages a second is what we're doing at peak through the platform. And this obviously spikes throughout the day, depending on how people are doing things. So that generates about 6.4 billion messages a day. Our Elasticsearch cluster, we currently have about 30 terabytes of data in there. Like I said, there's a retention of that data of 7 days. So yeah, we kind of monitor that to make sure it doesn't grow too much. And in the archive, we have about over a petabyte of data so far that we've archived. So what are the main challenges and lessons we've learned since we've done this? I guess this is true for pretty much anything that you automate. If you're going to make it super, super easy to create things, make it super easy to delete things as well. When you enable people to log everything, they do. And we found there were lots of things like Arthur's Test Service 1, Arthur's Test Service 2, Arthur's Test Service 3, and these all use up resources. So we now have a Lambda job that automatically does garbage collection on things that aren't being used. I spoke that we had that HTTP front door, which we call Slipstream. We're actually in a bit of quite a large amount of work at the moment to move all our producers to write directly to that. And the idea around that is we can start to have thinner clients that we give out to our different services and then put more logic into the HTTP front door. We don't have to make changes and expect people to update all their platforms as well. It gives us a lot more control behind the scenes as well. If we wanted to swap out Kafka for a different platform, for example, we have much more options for doing that. The other one we learned is that not all data needs to be always on or real-time available. The key is in the name of the talk. We're enabling you to log everything. We're not saying log everything all the time. And we do have to monitor some data sets that come in and we're like, this data set's 9 terabytes of data a day. Do we really need to store all this kind of data? So you need to be able to look at that and switch them off. Last time I gave this talk, a lot of people, the questions I got were, oh, I see that you're using Logstash. Have you considered using Kafka Connect? Or, Kafka's cool, but what about AWS Kinesis? We do constantly look at these things, and we do constantly analyze what would be good and what would be better. But, the amount of stuff that's out there in data, we could be spending our entire lives just upgrading things to the latest and the coolest thing. So, do upgrade when you think there's going to be some benefit to your platform or it's going to reduce your cost of ownership, but don't just upgrade because some guy on the internet said it was cool. And then the last one, I think we all build products and we all know that we need to go out and talk to our users and make sure that what we built is the right thing. But when you're building an internal product that's for your company, it's very easy just to say, this is what you should use and this is what you need. And you do actually need to go out there and ask feedback from your users, even if they are internal. One of the pieces of feedback we get is we've made it super, super easy to log everything. But there's still a bit of blockers in order to get the data out. So one of the other focuses that we're looking at now is how we can actually consume the data much, much easier. And hopefully we'll be back here sometime in the future telling you about how we've done that. So yeah, that's what I've got.